moves the rotor, and then from the rotor side bounce to the converter side, and from the converter you are able to take out the three-phase power supply. So how the power flow is being calculated? So here the mechanical power is nothing but torque with respect to the angular speed, and the stator power is nothing but the electromagnetic torque with respect to the angular speed. So the losses is being also calculated of the mechanical losses and the steady state losses of a generator, so on. So this is nothing but the DFIG model with the turbine speed on the x-axis and at the output of the mechanical power at different values of lambda and as well as beta. So in the case of DFIG model, we are having voltage and a drooping current connected to an adder circuit, that is nothing but VAC, VXS and Vreference even into a PID controller, which gives you a direct reference angle of current. And again we are having angular speed at the rotor side, voltage, current, angular speed again given to the losses if the blades are not rotating properly, if any fault has occurred during the momentum or during the rotation of the blades. So IS and IR is again rotor currents and the stator currents. IS is the grid connected current. Those are in terms of losses. So it's given to the again an adder circuitry and then to a PI controller, which gives you the quadrature reference of the current, and then simultaneously an adder circuit, total summation circuit is being given that forms a PI controller will give you the reference voltage with respect to the direct reference and as well as the quadrature reference as a total amount, right? This is a total result. So this is the grid side connected converter model. So here only IGC current, by means of that we are able to, if we change these values, this value will be varied. That is nothing but PI varied with respect to the grid connected voltage. So pitch angle. So another method to control is you can control the speed by using the pitch angles. By varying the different, just click on this, you will get different range of parameters. In that range of parameters, you can able to identify or place your values. So once the pitch angle is kept constant at 0 until the speed reaches the maximum point or the point D, that is nothing but the tracking characteristics. Beyond the point D, the pitch angle is proportional to the speed deviation from the point. So this is nothing but a schematic analysis or simulation of by using same power system software. By using this also we can able to have a required reactive power and the reactive active power of different ranges. So this is the entire simulation model for the DFIG. So a voltage is being supplied. See, you can give your own voltage. See, MATLAB is nothing but mostly sometimes you can use a trial and error based method, but an error will arise. What kind of error? Because you have to initialize each and every parameter in such a way that it meets the input characteristics or input parameters. Otherwise, it will give you a model error, and that model error will definitely confuse you. Way to identify how it will tell you that this error is coming over here, but the error is somewhere else. So each parameter requires its own characteristics and what value you are giving that. So for what purpose, whether it's for calculation of angular speed or the measurement of speed or voltage, current or the reactive power, and how much amount of torque is being exerted on each parameter. So see, nothing but generator data, displaying nominal value, stator value, rotor value, inductance value, inertia constants and initial conditions. So these are kept on matrices or looping systems.
So have you taken any example using this in simple also?
Yeah. Yeah, it can also be implemented in the same power system modularly.
We can, but it didn't use circuit.
We can. I haven't used it, but yes, we can. Okay. In that,
So
it is, see, in that what happens, there is no interfacing between the actual devices and with the software. But by using the MATLAB, you can have an interfacing. Either you can use the software through Kinect, or you can use through IDC or IDE, Integrated Development Environment. You can make a simulation or interface between them. Through SIP modulator, it is difficult. It can be implemented, but it is like the cost will be very high. So these are the outputs of all the parameters like voltage across the grid, voltage losses, power, reactive power, and to the plant, and the motor speed. The motor speed will be kept constant throughout. So wind speed is kept constant at 8 meters per second and at time with 5 seconds, and wind speed suddenly increases to 14 milliseconds. So this is just some variation and fluctuation in the pitch angle and the speed. You can able to observe. This is the actual motor speed and this is the wind speed. So this is again some more simulation parameters of the controlling areas. So conclusion. Coming to the conclusion, this model is nothing but a discrete time variant model where wind turbine turbine induction generator is simplified by using MATLAB and simulating. Operation of DFIG is controlled using AC to DC and DC to AC converters. DFIG wind generator and investigated effects of wind speed and pitch angle on voltage, real power, reactive power of a DFIG is performed in this system, or can be performed in this system. The DFIG is able to provide considerable contribution to grid voltage support during the short circuits, and either to the short, not just short circuit, either open circuit as well. Considering the result, the DFIG proved to be more reliable and stable. Okay, there are no yes, you can get some harmonics, but that harmonics, if you are using proper filtering techniques, that harmonics have been reduced and make the system quite stable. The rotor side converter is nothing but provides active and reactive power control of the machine with grid side connected and keeps the voltage to a daily constant. So the future works of this system is you can have eccentricity of fault detection system, and you can have easy, as what sir has said, fuzzy control of wind turbine and DFIG for integration into microgrids. Microgrids are nothing but small grids when connected. Differs from the actual grids. So we are having, as we have DFIG, we are having DOIG, that is nothing but double output induction generator by use of that, and use of fact devices with DFIG. So these are the references.